Okay, this is Chris Bankin again. We have done some tuning on this customer's car. I never claim to be the maximum effort, maximum power tuner. What I like to do and what the customer requested was a safe tune. And so we changed the injectors and we changed the fuel system components. And so it's important that the AFRs are dialed back in and that we're sure that the car is not going to detonate and things like that for this customer. So we've done some previous tuning runs on this car. We saw a little bit of knock, about 6, 7 counts, right around 6,200. And one thing about knock is, particularly if you're just relying on a factory knock sensor, is they don't always tell the truth the first time. Uh, Really, to be certain that you're getting genuine knock, you should do at least two pulls where you can see the knock in the same spot. This is not my car and not my engine, and so I would prefer to be on the safe side of things and not subject his engine intentionally to detonation, particularly when we're having to do road tuning in our strip down here in Mexico. Um, the road's not 100% consistent. You may hit a bump, things like that that can actually throw some things off. B, there's just some obvious risk involved to driving in Mexico, and I'm not trying to upset anybody and anything like that. So the first time we saw some knock, we actually took a little boost out of it, and we also richened it just a touch, and we removed about a degree of timing where it was doing that. So when the car came to us, it was running a Hellman MBC manual boost controller, which is one of the best manual boost controllers. And before we started tuning, we dialed that back 4 full turns because we wanted to start at low load and validate everything. And it's a good thing we did because even at 6 psi, the car was running a little lean. So we made sure that that was all safe before we started proceeding. And so basically, we went up a turn at a time after that until we got right back where the car was dropped off here at, and that's where we did see that little bit of knock on that one run. The other compounding factor is the local gas station here was 91 octane. And so the car was getting a little low on fuel. And obviously, we don't want to give a car back to a customer that's out of fuel. And I won't say we always fill them completely up, but I like to leave at least half a tank in the car, maybe a little bit more, just so the client, feels good about that and is able to drive the car right away. And also, you don't want to tune when your fuel tank's extremely low because you could face some fuel starvation that obviously could hurt your engine if your fuel pump pickup is uncovered. So anyway, so in addition to reducing the boost a little bit and the timing change and richening it just a little bit, I also grabbed 5 gallons of 93 in a can from around my house where we have it and mixed that in the tank. And so there's 6 gallons of 91 and 5 gallons of 93. And fortunately, all those changes combined at least really cleared it right up. And so we think we are good. And I just want to show how I like to kind of look at these and some small changes we may make to the tune kind of as we go along. So the first thing we do with our EvoScan log is we want to, at least in this case, I want to look at high throttle stuff. So you can go to the column for TPS. This is why it's important. There's some things you just really got to log. You really need TPS. You really need wideband, ECU load, timing advance is good, RPM, your fuel trims, and knock sum at the very least. And so there is a speed limitation to how many things that the ECU can actually log at the same time. And so the more columns you add, the slower your sample rate is going to be overall for each row here. And so I don't like to log a whole bunch of unnecessary things, but we are grabbing kind of what we really need to. Unfortunately, this car's got a really neat gauge underneath the radio that you can put wideband, and it's got a boost gauge in it and things like that, which is cool, but it does not have an output for boost. And so I maybe could have piggybacked off the actual sensor, but I didn't want to skew the results on that. And so we're relying on the old eyeballs to just look at the boost as we drive, which is not the best. But we saw that this car was starting out about 12 pounds, a little more at lower RPM, and then it got up to about 13 or 14 at the peak. And that's a really safe boost amount. Obviously, we told the client, if you want to tweak this a little bit, you can add your half turn of boost back into the boost controller. Just take a log and send it to us, and let's make sure that it's still not knocking and that sort of thing. This car is on stock intercoolers and things too. And at this power level, a third gear pull is a very long time on these. And it's just a long time to get your intercoolers heat soaked and things like that. And so you may see some knock. I don't like doing full third gear pulls over and over. It's just a lot of stress on the engine. You can see here we start all the way down at 2,500. Usually I start about 3,000, but I got a little bit lower this time. And we took it to 67 or 6,800 because we did see that knock at 6,200 yesterday. We really had to pull through that spot to validate that this is fixed. Ordinarily, maybe I take these to about 6,000 in third, and then if everything's looking great, you can kind of rely on the car is going to do basically the same thing from 6 to 7. I mean, it's not a bad idea to do one more validation pull from that range, but you just don't have to like do 20 pulls from 3,000 to 7,000 in third gear on these things. It's a ton of stress, and obviously the Mexican authorities and things like that you got to worry about. So, um, so anyway, I mentioned it in the previous video. We like to start out tuning them in second, but your wideband is obviously reading combustion after it's occurred. So, and then depending on where that's located, could be several feet from the turbos even, and several feet from the valves. And so when you're logging your wideband scaled, it's always a little bit behind. And there's some widebands out there that are faster than others. I know AEM claims their X series is one of the fastest. But regardless, the reason that you can't just do a bunch of second gear pulls and be okay is twofold. It's because your wideband is going to be off more because the faster the car accelerates, the more gap you're going to have between indicated wideband and what's really going on in the engine. And B, third gear is loading the car up more realistically. So you're going to have more heat in the engine. You're going to have more um, just load. And so if you have a boost creep issue, like the manual boost controller creeps a little bit. Um, Sorry for that little gap. Eli came in and was asking, we are doing a Haltech from scratch universal harness, premium universal harness on a car here, and he wanted to know if we want to put a new connector on the knock sensor or we want to splice into the old engine harness. And we definitely want to put a new connector in there, particularly on your knock sensor, as that's subject to a lot of noise. The connectors and pins and things like that are available from Sheridan Engineering and for the 3000 GT and Stealth. And so when we do a universal harness on a car, we buy like a complete package of all the pins and plugs and all that good stuff so that everything is brand new. Particularly the age of these cars causes some of the connectors to kind of get iffy and things like that and have green stuff growing out of them. So we don't want that. But back to this, the extra load stresses things out to the point where if it's going to knock, you should see it in third. First and second go by so fast. If you're knocking in first and second, you probably way out to lunch on something, or you got some kind of motor mount been bad or something, and the engine's just banging around making actual noise, and the knock sensor will detect that sometimes. It's called phantom knock. And that's another reason why some people prefer to encounter knock multiple times in the same conditions to be positive that that's actual detonation. And if you can, you know, get some detonation cans. They're fancy earphones that have a microphone that you can put on the motor. Particularly if you got a dyno. I know a lot of people still use detonation cans. Um, so knock is useful. Um, I've been tuning the 85 a long time on my personal vehicles and things, and so it's kind of not useful on that because the, the fuel tends to make the knock a little bit different frequency than say the stock ECU expects. where even the stock knock sensor is kind of calibrated to. So even plugging that into a Haltech, you may have some issues. And B, kind of by the time you see good knock on E85, you're kind of blowed up already. And so I tend to, and everybody should, tune things with a reasonable AFR, reasonable timing, and I don't push until we hit knock on a tune. I know if you're running pump gas, then you kind of got to do that at some point, but I would rather leave 10, 20 horse on the table, whatever it is, and have a car that's going to run in all conditions and not give a customer any trouble or give myself any trouble. Because knock is horrible for engines, and this is a stock piston engine, and so it wouldn't take a huge knock event to crack a piston. Additionally, knock is really bad on your rod bearings, and you can actually pound them out. And that's kind of universal over all platforms. But the 3000 GT kind of has, I'm not going to say small, but the rod bearings are not huge. And so it doesn't take a huge amount of beating on them to have a rod bearing problem. And so if you're spinning bearings a lot, first check through the whole oiling system, stuff like that, but also be sure that you're not experiencing detonation. I always get off my soapbox on these videos, so hopefully you guys don't mind. But kind of anything on your car, if you're blowing it up, find out why before you fix it. Okay, if you are blowing short blocks up or pushing head gaskets, bending rods, blah blah blah, you need to get to the root of the problem. Sometimes stronger parts is the answer, uh, but sometimes your tune's got an issue, and you put a brand new short block in the thing, and you're going to blow it up again and blame the engine builder, blah blah blah. Um, so figure that out. I mean, you could. I had an oil pan that was just too close to the pickup. It was an extended capacity oil pan, and I didn't spin a bearing, but it was starting to show copper in number six, turning a lot of RPM. And so I just pressed a big bowl into that thing and put another season of beatings on it, and it looked great. So that was clearly starving internally by the time I got to the number six rod journal. And, if I wouldn't have addressed that and tried blaming the guy that was working on my motor, then that just wouldn't get me very far, would it? So anyway, same thing with transmissions though too. Yeah, they're really old, and somebody before you probably couldn't drive. Um, the clutch dragged, whatever, killed your transmission the first time. But when you put a new one in, it's a big investment. You want to make sure everything's top notch, because if your clutch still drags, if your shifter's out of alignment, if you're a terrible driver, whatever, and you tear your transmission up, you know, hopefully the transmission shop's going to help you get in the right direction. But they're probably not going to keep rebuilding units for you if there's an issue with your car that needs addressed. And that's another reason that when I go to test drive these things, whether we put a transmission in them or engine or whatever, or tune or ECU, is we take real baby steps. I drive these things 3 miles up the road and turn around, come back, check everything out, make sure we're not leaking, make sure nothing's loose, nothing bolt things. We mark bolts when we torque them. I mean, things like that we try to do, and just checking all that stuff over with again, just to be sure everything's safe. And it's a big investment, and there's just no rush. Don't go out and do a red line whole shot as soon as you get your car run, and then cry that it spun a bearing and your car's piece crap. It's like, oh, maybe your car is piece crap. I don't know, but abusing it like that without knowing it's safe is a sure way to make any car a piece of crap. Okay. This isn't, a brand new Corvette you just bought that GM spent $93 billion getting the tune right, and you can just floor it as soon as you leave the dealership. It's something you built yourself or you had built. Make sure it's all safe and take baby steps and be comfortable with the car. Um, even cars making 300 or 400 horsepower, it takes some skill to be able to get the most out of the transmission and things. So kind of work your way up. And that's one great thing about this car, laying the foundation for all the mods that he wants to do in the future, is that he's learning all this and figuring all this out and making sure it's all stable. And so when we put bigger turbos in it, should be a graceful change to that and just make more power and need a little bit more tuning and things like that. He didn't go put in, 67 millimeter turbo and hit the key and do a red line hole shot and scatter rods everywhere the first pull he did. So this is kind of the way to go on these. And that's why I recommend a lot of people, they do all these mods and try to get by. on the stock ECU or some tuning device that's piggyback, whatever. If you're going to do some mods to the car, the first thing I would do is ECU upgrades and then get to learn the system, because when the car is running on stock turbos, it's a lot harder to blow up. And so you can learn and make mistakes that aren't as costly when you're on a stock type of power setup. And so, I think if somebody wanted to learn how to tune and they had a 100% stock car, put a Chrome in it, put a Haltech in it, whatever you got, and learn how the system works, get it to run great like that. If you cannot get the car to run great on 9Bs, then you're not going to be able to get it to run great on bigger turbos. It's not the bigger turbos holding you back as far as getting a car with great drivability and safety and things like that. So anyway, I've soapboxed enough. Let's take a look at this. So again, I've filtered out our TPS because I don't care about anything other than high throttle here. I think my mouse just died. Nope, there it goes. Thought my mouse was dead. We're back. So what we're going to do here is we're going to be looking at engine load. Okay. We're going to be looking at RPM, and we're going to be looking at a wideband scale, our knock sum, and some other corollaries here, but not as important to our current predicament. So again, like I said, it takes a little time for the wideband to actually read what's going on. And if you look at these things, you got like 4 or 5 rows per second. So it's unwise to make big changes based off the first few rows in a pull here. So you can see here, we may as well go down to when it's really starting to do the power enrichment here at 2500. So what we'll do is we will pull up our ECUFlash. Let me get this resized so you can see it in the window I'm capturing. So we're going to pull this tune up. You can see here we're on iteration 7, which, don't feel bad if it takes a lot, but luckily this car didn't really take a ton to get there. When I daily drove my Stealth, I had like 300, and so I was just really refining every little startup, every little thing. And we were running big injectors in the 85 and that, and so it was quite a bit harder to get that to cooperate. So we said we were at 2500. Let's go look at what load we were at. Just gonna pull this down a little bit. So 2593 load, and we are getting an indicated 13.6, which is probably pretty safe at that lower load and that lower RPM. But let's take a look. So 2590 load is in fact 13.6. So, and you got to use a little common sense here. Okay, there's not going to be a column for 93. So you need to look at, what makes the most sense in terms of how you're kind of interpolating these. So I'm looking at 90 here, which the 100 to 120 is kind of when the car starts to make 5 or 6 pounds. So this is kind of your economy area in the tune. So don't worry when you're at 2000 and you're getting on it. And you shouldn't really floor the car at 2000 in a high gear, but you get the point. It's designed to not need that much fuel cooling and things like that at that point. It's trying to save fuel. So 2590, 13.6. What do you know? 13.6. So we got that pretty dang dialed in. So next, I'll kind of go up to the next block of RPM. And obviously, we want to keep an eye on our knock sum column. I like to tune to where there's not any. But if you see 1 or 2 occasionally, it's probably not real knock. You start seeing consistent knock amounts in here, you need to fix it. Especially when this starts getting to like 7, 8, 9, 10. You're starting to see 20 in here, you're like in danger of breaking the motor for sure. But I would not tune a car to where it was running consistently at like 7 even. Let's just not do that. So 3,000 and 144, we're running about 13.5. So if we go to our 3,000 column and 144, it's calling for 12.9. So we're a little bit lean there, and nothing that I feel is going to be hard on the motor, but we can add a little fuel there if we want. Let's see what the airflow is. So our airflow is 962. Yeah, 2 byte airflow. And you do need to make sure you're logging 2 byte airflow. If you're logging 1 byte, it cuts off real early and you can't read high numbers. I think 1600, something like that. Uh, so we're doing 962 airflow, and let's see how lean we are here. We are running a purported 13.5. We want to run 12.9. So if we take 12.9, we're about 4% lean there. Okay. Which again, I don't think this is going to hurt the motor at all, but let's get a little closer than that. We can do that. It was 953 airflow. So if we go down to our math scaling table, math smoothing, I keep calling it scaling, it's not. So sorry you can't read this, but we got about a pretty high value here already. But we're just gonna go up, you know, baby steps there. That's gonna give us another percent because this is already pretty high. I don't want it to like jerk going to these next things. So we'll give it one there and one there. You could add the full 2%, but I just don't think this needs it. And I don't think it was ever lean enough to make that big a difference anyway. So I'm going to go ahead and save this while we're talking about it. And I'll increment my number here so we can always go back to our previous tune if we make a mistake. We don't like the way it runs or something. And let's go back to Excel. If I can get my computer to cooperate. Okay, so now let's go to 3500. So 3500 and 1100 load, we're running 13.3. So if we go to 3500 and 130, do we say 113 load? Oh, I'm sorry. Let me look again. 143 load. Okay, so 140 load and 3500, we're calling for 12.6. And again, that's just a touch leaner. And again, that's not going to hurt anything at 3,500 RPM. If you took a factory car out and did this, it'd probably be similar or richer even. I mean, leaner. So that's 1153. We already added some to the adjacent rows. So I think we're going to be okay when that ritens up just a little bit. So let's go to 4,000. So we got 4,150 load. We're at 12.5. So if we go to 4,000 and 150 load, we're a little bit lean there. And again, that's low enough RPM below peak torque and things. It's probably not a bad thing. And you can also see the adjacent cell here is 12.5. So it's going to kind of be impacted by the cell above that and below that. So let's go to our Excel again. This was 1,300 load. I'm going to go to my mass smoothing table to 1,300 up here. And let's chunk another one in there. And its little buddy right there and make sure that we're good here. And regardless of what people think, on a turbo car at least, an old turbo car, a couple of tenths of AFR is not going to lose you a bunch of power. I'd rather this ran fat and happy when it left here than try chasing that. It's just not going to make that much difference. Okay, so next we'll hop up, and this is when the car is really probably going to start richening things up. So if we look at 4,500 and 150 load, we're at 11.6, which is great. So if we look at 4,500 and 150 load, we're commanding 11.2. So that's pretty good. We're a little bit lean there. We did add 1,571 is about 1,600 on our mass smoothing tail. So I'm going to add 2% there. Whoops, in the wrong cell. Why this is not cooperating. There we go. So I'm going to add about 2% there, which will get us right about where that needs to be. If we look at our calculator, I think we were running 12 or 11.5 and we're wanting to command 11.2. So 11.2 divided by 11.5. Yeah, we're about 2.7% lean. So that should fix that or be really, really close. And so let's keep going. And again, these are minor changes. I've gone through a couple of rounds with this. Obviously, if you're way off, make bigger adjustments, okay? So if we go, I definitely wouldn't lean it out all at once. If your car is running lean or your car's running rich, don't be like, oh, I'm gonna take 10% of the fuel out and see what happens. I go a little bit less than that. I tend to go about half the distance. So if my car was a point rich, I'll try to aim to go half a point and see how it reacts and take another log, okay? Um, it's just a lot safer to go a little bit slower like that. So if we go to 5,000 and 150 load, we're down here, and I'm commanding about 11, 10.9, and that's exactly what we got. And so we added a little bit of fuel to the 1600 range, so that is going to take that to about 10.9. And again, I have this set up for safety first and foremost. Um, on pump, you can get away with like 11.5 at high RPM and high load and things like that, but it's just not worth it. I mean, that half a point is losing a lot of safety factor, especially if he has to put 91 or 89 in or something like that for a little while. It's just not worth it. On E85, I even run like 11.5, so I don't push that super lean either. If you run high quality race gas and you want to run up in the 12s, that's your prerogative. It's just on, inconsistent pump gas. I don't want to do that. So let's go down to 5,500, and we got 146 load and 10.8. So if we go down to 5,500, 150 to 160 load, we got 10.9 in our map here. And there you go. So we're extremely close on that. And you can see here the rest of this pretty much does the same thing. It pretty much holds at 11. If we go to 6,500, for instance, and 130 load, you can see the load starting to drop off because our 9Bs are running out of steam here. If we had boost data logging, we'd probably see that start to go down too. So we got 6,500 and 130 load here. We got 11.1 and we're running 10.95. So, I mean, there's just no need to play with that. That's going to be fine. And it's the same story for pretty much the rest of this. So other than a couple of spots, we added a little bit of fuel to our math smoothing table. And at the top end, we added just a little bit. We should be good. And if the client wants to go in here and take 5% of some of this out of here, it's probably going to be fine. They just need to validate that themselves. I'm not going to run it that lean. And if we had a dyno, it'd be a little different. We could see how the car reacts to that and see if it really likes it leaner or richer. But you'll even see stock cars running down like low tens. And so don't feel bad about this. This is just going to be safe. Okay, so the next things I want to look at now that we got the power pools kind of straightened out, which you probably aren't going to spend a lot of time on power pools unless you got really pushing things. You can see here, we dialed this wide open stuff in like 6, 7 iterations, and some of the first iterations were just changing idle tuning. So it really didn't take too much. Let's take a look at our knock sum, and it's all zeros, which is great. Yesterday we saw like 4 or 5 up here at 6,200 is why I wanted to fix that. So we did. Between the extra octane, probably a little bit less boost, etc., we fixed that. You can also, when you're in here, you can get an idea of kind of what timing you're running. And so at the top end, we're running about 20, which is appropriate because the stock tune actually runs about 22 at the top. So it's a little bit conservative on timing as well, just because, again, we smoothed out the timing map, and I want it to be safe, and we don't have a dyno where we can really start adding timing and our track ready for us so we can really start confirming that the timing is actually making an improvement in torque. So what you want to go for is minimum timing best torque. And this just means you're trying to run the least amount of timing that you can. So because it's not how much timing the car will take, it's how much it wants. Okay, you're just trying to get the burn to be complete and be pushing on the crankshaft in the correct rotation. I believe it's somewhere 20 degrees after top dead center where the maximum force is exerted on the downward force on the rod. And so That's going to vary from engine to engine. 4G63s run less because they have a smaller bore. Okay, they make some more of their displacement with stroke than we do, and so when you have a bigger bore, the flame propagation takes longer. So it needs more timing. We also have very small hot sides on our stock type of turbos, and so they naturally tend to do a type of exhaust uh, recirculation, reversion, basically. And so some of your charge is getting contaminated with exhaust inside the motor when it does the next combustion cycle. And so they need more timing for that. So if you go slap big old honking turbos on your car, you're probably going to want to remove at least 3 or 4 degrees from this type of map and start out with that. Uh, there's plenty of stories about people putting huge turbos on their cars and running the stock timing map and blowing their stuff up because the stock timing map is designed for a restrictive hot side. Uh, and if this car ever starts to see a ton more load, it will naturally start to reduce timing thanks to Greg's big maps here, whereas the stock stuff just kind of stopped here somewhere around at 160 or 180. Um, so if the client does start turning up the boost, our timing is going to get safer and safer. And, that kind of makes me feel good knowing that if we hit parts of this map that we didn't expect, it's still going to behave in a safe and reliable fashion. So that's that. That's our power tuning. That's our timing. I want to look at our trims. Our trims could use a little bit of tweaking yet. The fuel trim low is 4, which is totally fine. Okay, you're going to chase your tail a lot if you're trying to get this to 0. If it's plus or minus 5, you're pretty good. So this plus 4 is great. Our mid trim is a little bit high. So this being high, and the mids are kind of around the 100 airflow area. So I didn't do it on camera, but I added to our mass scaling table in this 100 area, I added like 3% here, 3 or 4%. And so we'll kind of see what this does. And the client is picking up the car on Friday. And so I encourage them that if they want to send logs later, they can do so, and we can make some minor tweaks like that. It's important to get these trims, particularly the high trims, which are kind of hard to get it to actually want to change. Uh, it's important to get them close because there's some debate on the 99 Flash ECU whether or not the trims will impact your wide open AFR. I kind of lean towards it does a little bit. I know the original ECUs didn't really care, but the newer ones, they kind of started to do that. And so with this mid trim being high like that, it may be adding a little fuel to the wide open. Since we're so rich anyway, it's probably going to be fine, but I'd like to get this mid trim down a little bit. And also, one thing you have to keep in mind is unless you're looking at your short term fuel trims at the same time as your driving through this exact range where it's doing this mid trim, you don't know if that's really 12. This could be 25 because it just peaks at 12. I don't think it is, but so that's why I added like 4 or 5%, and hopefully we see this number starting to come down. Obviously, I don't want to drive a customer's car all over creation, things like that, but uh, we'll get that a little bit closer. And also, like I said, the client can do some data logging. He's savvy, and he can kind of let us know if that needs some more tweaking. You can still see here our rear and front match, which is kind of unusual, but that's great. And the rear mid is actually closer, so that's only 9% off. So that's why I think this is not much more than 12. I think it's probably right on the edge. So hopefully this comes down to about 8. And this will come down to about 5. And if we need to, that can be tweaked a little bit more, but that's kind of getting in the realm of you're okay. It's a little harder to hit these mids consistently, and the car basically refreshes its long-term trims every 4 minutes. And so you would have to drive quite a while to get these mids to start to move around much and that sort of thing. The idle's easier. I mean, it only moves every 4 minutes as well, but you can just leave the car sit there and run in your driveway, and you can see what this does, and so that's a little bit easier. Uh, if we had a load-bearing dyno, you could put the car, 40 miles an hour or whatever this is, and do the same thing, I guess. But enough driving would solve this, but it's not a big concern right now. It's not causing any drivability issues, and I did take some measures to get this down. I just don't want to go this full 10% here all at once and have that swing way past too lean. Some other things we log. I like to log speed just because it helps me know what gear we were in. If we're doing a long log and we did some first and second gear pulls, I like to log speed and that sort of thing. So this is pretty well wrapped up. We're going to clean the car up, check the fluids and such, and make sure everything's happy and get it ready for pickup. We did do, there's a program out there called Virtual Dyno. It's written by, I think Adam Barnhart. Is that his name? Let me look here. Brad Barnhill. Okay, I knew something about that. And what it'll do is it will do an analysis of your log given the car's parameters and try to estimate your wheel horsepower. Um, and if you give it the right variables, there's been plenty of evidence to suggest that it's pretty close. And so you can take this with a grain of salt. Um, but in my opinion, this is kind of in the realm of what the car should be doing. Remember, we're only running like 13 or 14 pounds of boost. And so making about 300 wheel is kind of what I would expect. So we're showing about 300. The car is really heavy because we're two big boys in here and it's all stock weight. And so we got a lot of weight to pull with that. Um, and so this is kind of what I would expect. So car leaving here with 307 wheel and no knock and a safe AFR and transmission that shifts great. I'd call that a success. I'm happy with it. There's probably 20 more here without changing any parts. But again, if you want something that you can just drive and not stare at gauges all day and not worry about it exploding on you, I feel like this is better than having 320 that I got to babysit constantly. And I'll leave it up to the client if they want to turn their boost up a little bit or whatever they want to do. But I'm really happy with this outcome. I think the client's going to love it too. And it was a joy working on a car this nice. We're very, very fortunate. We have such great owners that are taking care of these time capsules and also modifying them tastefully. And so this is a great level for this car. He can put a bigger turbo in here and make another 100 horsepower. I'd probably recommend a water meth kit at that point, which will let him, he can run 15, 16, 17, 18 pounds of boost, and it'll pick up 100 horsepower with that sort of setup and a little bit bigger turbo. I think he's going to be looking at like a 15T or 16T. Larry McCoy builds some of those. We have a car here currently. We are putting billet DR650s on. We're a dealer for dynamic racing as well, and so that's going to be a sweet setup. All billet. He's debating going with the high flow turbine wheel, the lightweight one, things like that, because he wants to make closer to 500. And I think it will with that kind of setup. One thing I will say about tuning is on pump gas, these cars are quite octane limited. And putting freer flowing turbine housings and things like that can help a lot. But don't think that just because you put a little bit bigger bolt-on turbo on here that you're going to be able to run 25 pounds of boost on pump gas. That's probably going to end with a bunch of broken parts. So take it easy. Pay attention to the knock sensor. On pure pump, I'm definitely not comfortable over 20 pounds. If you get a meth kit, okay, you can do that. And I've people that run huge meth kits, they even run like 30 pounds of boost with them, but that stuff really helps, particularly on a car like this that has the stock intercoolers. So anyway, that's my last on that piece. If you need your drivetrain rebuilt, see us at rvengeperformance.com. We are currently doing an entire drivetrain and engine out service on a car here. We're simultaneously rebuilding the transmission, the rear end, the transfer case, putting a heavy clutch in it, doing injectors, DR650s, a whole bunch of stuff, fuel system, a bunch of great stuff. So we can do top to bottom, whatever you need at our shop here in Missouri, and we can help you transport your car here or whatever you want to do. Or you can freight your transmission here and we'll do that for you. So we can kind of adapt to whatever you need. But this has been Chris. See us at rvengeperformance.com. We're on Facebook under rvengeperf, and we're also on Instagram and YouTube, obviously.
Revenge Performance is the place to get the parts and the advice to help right the wrongs on your vehicle. We partner with the industry leaders in parts distribution and warehousing to get you the best possible prices, the widest selection of parts, and the fastest shipping. With our real-time inventory on our website, if we say we have it in stock, it's ready to ship. From us or from our many national distribution partners. With hundreds of thousands of parts available, I guarantee we can get revenge on your ride.